So we're nearly done now. The last thing is to have these buttons, when you click them, request to change the mode with the service, and then when the service confirms the mode's changed, update the class on the buttons, and then we can link in the real code to control the actual multimeter. So this will be a two-step approach. The first thing is we want these buttons to be not have the active class, I guess, to start with, because that's going to get added for us. So let's remove the active class. And then every button that we click, we need to now call into a function on here, or the single function, which is basically change mode. Now, if we look at the change mode, we did miss one thing, which we've already got the mode change. So if we did in the constructor, I believe, this infinite loop, let's swap modes automatically. When we change modes, we want to update all the values, get to here, data changed, which includes the mode, but I think we potentially want to, now let's not have another function, let's keep it in the data changed, so we've already got the function. And we want to update the mode in here. Actually, no, let's do one. Mode change isn't that often, and we don't want to have to keep rewriting classes and bindings unnecessarily for a mode. So just in case it adds a little bit of labor to the UI, constantly resetting buttons, let's have an event for specifically the mode change. So we'll go to public events, data changed, and this is for the buttons. Because it's such a limited time event, we don't want to keep doing this for every 5 times a second on data changing. So we'll have mode change there, and then when we do actually change the mode at the bottom, we can do mode changed. Now we can hook into here and add one more callback, and then do mode changed. And now in here, the only job of this is to remove all of the classes, or we could potentially bind, but we could either do binding or do it in code behind to remove and add the classes. It doesn't make much difference here. But we are going to have to, because the buttons are all just single buttons, we could just go through, I think we'll just go through and name every button. Again, keeping it simple for now. So name button VDC. I'll just do this for everyone. Button IDC. Ohms. Continuity. So that's all the buttons named. Now when we change mode, remove all active classes. So that can be button, we should be able to access it. Oh, we're in the view behind here. So actually, let's think of this a different way, because we can just still access the view model. Oh no, so let's just access the view model. So var view model, what we can say, if data context, there's a point, we don't have the data context. Which way around do we need this? No, we've got this backwards. We want this event to change some binding. So let's just have a binding per button, actually. So we don't need the names, but we'll leave them in. But what we will do is make a observable property for every button class, basically. So we'll have, or every active button class. So button VDC active, in fact, it can be a Boolean. It can be false. And then we copy this 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Name all these the same: voltage AC, current DC, current AC, capacitance, resistance, diode, continuity, temperature and frequency. And now they're all active false. When we change mode, we can make all these basically false. So capacitance, that's all of the buttons disabled. And now we want to bind these to the specific, in fact, we could actually change this logic to say mode I don't have mode. didn't store the mode actually when it changed by the looks of it. Because, oh yeah, so we need to also store the mode change as a property, and then we can keep hold of that. So, or we don't even need the mode in here, but let's put it in here anyway. Multimeter mode, and we'll literally say multimeter mode equals, and then we'll just put unknown to start with. And then on mode change, we actually want to change this call to have the mode in. So at the exact time, we also know what the multimeter mode is. So we can react to the event and not have to read the property back. Or, no, let's keep it simple. The property's on there. Let's just keep it exactly the same. And this can be just reading from the multimeter service.mode, like that, equals. And then if this equals voltage DC, then it's going to be active. And we'll just repeat this logic actually for everything. And that'll automatically set the active mode correctly based on the mode. Right, so that should be all we need for set all active classes. That should be all we need for this to respond to the actual changing of modes, and the buttons should now link to the modes. There we go, so reconnect now. These buttons should highlight automatically, and they don't. Oh, we haven't done the binding. So the last step is to bind every button to that mode. So the way we do that is saying here, classes and then dot, and active is the one we want, and this can be a binding to the voltage DC button active, and then repeat that for every button. That's all them buttons bound in. So now we should see the buttons basically get selected as we're in the specific modes based on the callback. Yes, there we go. So now you can see it's cycling modes correctly. You kind of see that slight flicker of white between modes. So I've gone ahead and added some transitions to the colours as well. So on the border where we have the multimeter colour, I've added a transition of 0.2 seconds to blend the colour, and the same on the label. If we run this, let's see if that fixes that little white flicker. No, there's a little white flicker, and this is not changing colour quick enough. So see how slow this is at changing? We should be changing within 0.2 seconds between the colours, and we're not. So something's probably locking up the UI thread somewhere. We probably have to investigate that after. The solution would be to disable the transitions for now, but obviously there's some kind of underlying issue there, I think, with something holding up the UI thread. So let's ignore that for now. Move on to when we now click the buttons, we want to tell the multimeter service to change mode so it's not automatic. So we'll disable the automatic one with increment mode. We don't need this anymore. We'll leave it in just for now, but we don't need it. And then each of these is going to have, we want to set a pending class when we click to change mode. And to be honest, I don't know whether we want to, I don't think I want to bother with the pending class, to be honest. Not for now. I think we'll just have a click button and tell it to do the command to change class. So in here, we will want a relay command, and then we'll have private void change mode. In here, we want to pass in the multimeter mode, and then here we can just simply say multimeter service dot change mode. And that's all we need. So then we can bind these to the buttons in XAML, and we should be able to do this all in XAML. We go to a button here, button control headers. So first button here, if we do a command, we should be able to just do binding change mode command, and we should have a command parameter as a second. Yep, command parameter binding, and then is it static? So I think it is. I'm sure it is X static. Oh yeah, of course we need the namespace. So this would have found it, but we need to do the namespace binding, which is in this case just the streamelectronics.multimeter. So we need to add that as a namespace at the top. So we'll do XML namespace colon mm for multimeter, I guess. There we go. And now we can go back down and we should be able to find mm. Where's the first button? Here we go. So now we should have mm colon. There we go. Multimeter mode dot, and now we can pass in the voltage DC. So that should tell it to change mode. We copy and paste that between each button. Same idea again. And this time just change the mode. And that's all I'm done. So now we have the command and parameters bound per one. Let's see if we can change mode now. So enable, goes to voltage, tab between, yeah, so we're changing modes nice and easy. Oh, that's the problem. It's not changing color wrong. This is actually the automatic counter where it fades between colors. And I think we have, when you change color, when we're clicking, it's trying to change the color to this purple and this blue. But we have that other code at the minute, the live value test code, that's changing the color as well at the same time. So we've got this contradictory color change as well as the mode color change. I think that's the whole problem with the color fading. I don't think it was actually a problem. It's just that we were having two things fighting for the color. So now, there we go. Yeah, so there isn't any lockup on the UI. And that fades nicely between the colors. Yeah, so that's gorgeous. So now we can select modes. We can obviously enable this color change for when the value counts up, but this would be limited to the mode. So what we could do is leave that test in and just say if mode, which I think we should have now. Yep, if mode is voltage DC, only do this automatic color change in voltage DC. And that should allow us to still see that voltage change, but also tab between modes. So this should now start counting up and changing colors in the voltage mode nicely. And we can go to current, back to voltage. And that's what's going to happen based on the real values. That's perfect now. So that's all done. So this is now a fully working application. We just need to actually make it work with the real meter. So one thing we'll need is we want to save this ID so I don't have to keep pasting it in. So we'll do a very simple thing. When we enable and disable, we'll just write that to a file. It's the only setting this entire application is going to have. So I'm simply going to say where we have the enable, where do we do enable changed? So in enable changed here, let's just write value, write visa value to file. Try exception, we are going to ignore, we just don't care for now. And then in here we're just going to say file dot write all text. We're going to do the visa ID and it's path first then content. So the path will just be visa ID.txt. Let's keep it super simple. So we're just going to write it straight to file every time we change or every time it is enabled. So if is enabled. So once we go live, we want to write the data. And then on opening, so in the constructor, we want to read that back in and set the property. So do we have a constructor? We do not. Well, we do, but it's an automatic one. So this is where we could do with the loaded callback for initialize. And we have initialize here, so this is where we'll read it. So read visa value from file. Read all text, visa ID to visa ID. And what we can say is file.exists, just for the sake of not crashing for no reason. And yes, I know we could move this to a variable. Don't really care how small it is. Read all text, and then visa ID equals what we read back. What's that complaining about? Add set accessor for visa. Oh yeah, it's not got a setter. There we go. That should now store to file when we enable. So if we do test, enable, that should have written to file. So I guess we can check that. Open up in Explorer. It will be in bin debug.net, and we should have one in here called Visa. There you go. So it's written that to file, which now means if we turn this off, we could change this. That won't change because we're not enabled. Close, reopen. That should have saved now the setting. So super simple setting. Obviously hasn't. Or if it has, something's overridden the value. So let's close that. Reopen. This reads, it gets it, it sets it. So yeah, we simply have some other issue going on. Do we set it again anywhere? We must override it somewhere. Don't know if that's going to call a getter. Interesting. That should be bound. Oh, it's a public. We don't tell the UI when it's changed. So we need to manually tell it that this is changed, or we need a backing field. So we'll probably just do a observable property, make that private, make that underscore visa and blank, and then I think that's it. I think that entire change will now work. There we go. So now we have the value stored. So the only thing left to do is to make this work with the real multimeter. So let me just show you the code I wrote before this. This is the code that took literally about a week to figure out. And you can see I wrote a small project to give it the same name. And the only thing in here of any relevance is I made a view model. And basically this is the entire code right here for reading from the multimeter. And you can see it's like less than 200 lines of code. And I made a little view model, and it didn't even use the view model. All it did was dump out what we're attempting to read to the command line and attempt to switch modes. So I could see that this was controlling my multimeter. But obviously this is just a permanent loop, not really very well structured. It was just a proof of concept before I decided to make this application we've done. So what we need to do is move this over now to the real application. This we have, so I'm going to move this over to the, well, I'm not going to move it over. What I'm going to do is run the application, save that in, because that'll change every time. Enable it, and then I can disable it. So now we've got that stored. We should probably say, well, actually the visa ID can be anything. We'll probably just move this setting or this text over to the visa property here, just so I've got it somewhere for reference. That we also need to install, if you're going to do this with if you have a Rigel multimeter, you have to install something called Ultra Sigma. Now I can't include this because obviously it's not my software in a sense. This is the Ultra Sigma, and all you need to do is install Ultra Sigma to get that ID. So this ID, this one here, came from installing Ultra Sigma, opening it up, and it tells you this is the ID of your multimeter while it's on the network. But it should also be possible without that, because it's always going to be TCP/IP : the IP address, which you can get from your router, : instrument. So you don't even really need Ultra Sigma to figure this out. Now we know what it is. But the other thing you need is this visa. So this is the standard for electronic equipment that supports it, talking over the network, or even just talking in general. This is like an API for multimeters. This is made by National Instruments. And again, I can't give you this. You have to sign up to National Instruments. And you also have to do is type into Google NI Visa. And it takes you to this page, NI Visa download. And then you have to just sign up, log in, and click download, and then you get the file. So you don't have to do anything except you really do need to just read the terms and conditions. And you can see it basically says it supports customers for Ethernet, GPIB, serial, and USB of other types of instruments. So this is mainly for high-end electronics equipment. So you have to install that as well. And it tells you otherwise things like Resource Manager don't work. Saying Ultra Sigma isn't needed except to get the IP, which is right. And then this is obviously the IP. So that's the notes done. Next up then, we can delete things as we go, I think, in this other class. I just had a random index here for the modes, so we don't really need that because we now have an enum. The modes, this is important. These are the modes that we want to get. So we'll take these, and this is if we want to measure. So this is the thing that gets the live value. We send this command. So we need to convert this over. And what we'll do is probably make a what shall we do? Well, the logic will live in here for that. So the live value, what we can do is say var mode string or value read string equals, and then we can do a switch on this. So mode switch, come into here, and now we can say VDC. Oh, that's not that one, it's mode. Now it can be VDC, and is it that? And then we can do volts DC, and then we need to do it for the rest, basically. And I suppose just before doing this, we want to copy this dummy multimeter service, because we actually want this to be kept in. We still want the dummy one. So we'll call this other one Rigel multimeter service. And this one can be, we won't need then in the dummy. Well, we'll keep that in the dummy actually. Should really be in its own file. Multimeter mode, let's just make a new class. Multimeter mode. And let's move that out of the dummy. That's there. The Rigel now wants to be Rigel multimeter service. The constructor will have to be that as well. And now we have both, and then we can make an interface, or we can just create the different one. We'll probably make an interface and just inject the different one once we're done. So now if we went to the live value again, we won't have live value test anymore. So in here now we don't have a live value test, we want the mode string in here. So then I'll fill all these out with the same ones. So now we have the string we need to send. The live value here is just getting a random value. This is the multimeter, so we want to keep this code, this is right, but the live value is what we want to change. And that's the point actually, live value, that actually might change, I'm not sure what we get back. So we'll figure this one out in a minute, but if we go back to the helper code, we have the mode names, we don't need that. Welcome to Avalonia, we obviously don't need that. These helper functions we're going to need. This helps us to just basically use the API to send raw strings as byte arrays, read them back and convert them basically. So that just is helper functions for the reading and writing. We'll put that in here. We'll have it in methods at the top. You can see here as well, we don't have the NuGet package installed. So what we need to do is there's a NuGet package and it is called nationalinstruments.visa, I believe. So if we just type in here, national instruments. So you've got national instruments there, .visa. So let's install that. And that is the API. It's just a wrapper function around the TCP calls that helps. With that installed, if you don't also install the National Instruments Visa EXE that we mentioned, this here, this the one we should have downloaded. If you don't install that, the resource manager will throw an exception saying it can't find the DLL Visa 32. So if you want to follow along, you need to install that. And now we should be able to do control dot and find those files. There we go. This is complaining about something, use var, okay. So they're the two helper functions for that. Now this is just a main loop, so there's nothing else left except the loop. So what did I do in here? We basically newed up these, and you can see the usings, so these need to be disposed of. So we need a resource manager first, because we need to keep these in reference and dispose of them. So private resource manager underscore resource manager. This can be null as well. So let's make it nullable. Shouldn't have to specify null actually, it will automatically be null. Same for the message-based session. We want private message-based session. So those are the two values we need to create now. So we want to do this using, and we're not going to use the using here because we're going to manually dispose. So ours is just going to be resource manager is new, and we'll do this when we connect. So this is where we connect, and we should only connect once because this logic tells us to connect. This is the protection. So in here now, this is where we want to really do the connection. So we'll try to set the resource manager to a new one. If it fails for any reason, then we will do resource manager (.dispose). We'll attempt to dispose and set it to null. And we'll do the same for the session (.dispose) and null it. So we just want to clean up if anything goes wrong. Otherwise, we are fine here. So after we've done that one, we do, and we can delete this as we go. We can do this one for the message. And this basically uses the resource manager from the API to create an open TCP session, attempts to connect to the multimeter on the Visa ID. So this could also fail opening. If it does and crashes here, I guess we could report as well, clean up, report problem. And this could bounce up to the little, so device name equals error, and status equals error : error plus message. So we could do that to bounce up the error if it fails to open. And then what we want to do on disconnect is we want to do this, basically dispose again. So disconnect, clean up, do the on disconnected. And on disconnected, we don't have that test value anymore. Yep, I think that's good. So now we should have, we'll leave it at that. That should attempt to just literally open up a session to an ID. And if I don't think the multimeter's turned on at the minute. So we'll see what happens there. Oh, live value test, we're going to have to comment this out for now. And we also need to tell it to use the new one we've made. So let's just do dummy service, show context menu actions. We should be able to extract an interface from this. I rarely do interfaces, so I'm sure there's a way to just automatically extract an interface in Rider. So it's got to be in this context menu somewhere. Refactor this maybe. There, extract interface. This will now be multimeter interface is connected, enabled, Visa ID device, live value, mode caller connected. Yep, we want all of them. So let's extract that. We should now have an interface somewhere. What? Was I meant to check options there? I think I just didn't check anything. I thought they were all checked by default. You can tell how many times I make interfaces. Refactor this, extract interface, its own file, select public, connected, unconnected, undisconnected, fetch device name. No, they're all values we want. Access rights for that. Yeah, you can extend them, that's fine with it being an interface. Why is it named the file? Did I not rename that? And there we go. So now we have an interface, multimeter service with all of them methods. We don't need to do anything else because that is already implemented naturally. Now we need to do, why is this now called multimeter service? Have I renamed the wrong one? Yeah. This wants to be the dummy still. There we go, I think I renamed the wrong thing. And the I service here is there. So dummy multimeter service. Now we can do Rigel multimeter service. This goes up, implements the interface I multimeter service, which it already will. And then we can now do in dependency injection. Instead of doing add transient dummy multimeter service, we want I multimeter service and Rigel multimeter service. Is that the right syntax? I can't even remember. Service and implementation, yes, so that should be correct. And now in the, where are we? Got that many files open now. In this one, nope, in the view model here. This now wants to be an I multimeter service, not a dummy. Rename that to multimeter service, and then see if anything else needs changing. Does not implement interface on connected. Yes, it does, but we have to change the access. So from protected, I presume that goes public, does it? The other one will be on disconnected public. And fetch name public. There we go. So if this works, I can't remember what we were expecting to see now. Oh, this should now actually hit the. We're done with the dummy, done with the mode. This should hit the actual attempt to connect here. And I presume it will crash because it's not turned on. But it's on, but in standby mode. So I'm going to presume that's going to crash. There we go. Insufficient localized information for the device or resource not present. Cool. So that's literally going to complain. Why have we hit a second time? Why are we hitting over and over? Oh, because that's what the code does. So the code's going to fail on that, and every 0.2 seconds it's going to attempt to reload, which is a bit aggressive when you've failed. So what we'll probably do is when it fails, we'll report it. If we have not connected, so really the only time we'll get in here is if we're not connected. Let's just do an await task.delay 2 seconds. Let's just not spam. Don't spam, reconnect. Now, I think we'll have to, because we're running this asynchronously, we don't want to change us connecting to false. So let's actually, when we're finished, either way, I don't know what to do in this case because, we just don't want to spam. Let's just flag it. Let's just say, do a little helper error, connecting equals true. And then we'll just do error connecting equals false. And then we'll go into here, private boolean error connecting equals false. And basically what we'll do is if we set that flag to true on this loop that we're looping fast here, we won't do attempt to reconnect. If we have error connecting, wait 2 seconds. So the whole loop itself will wait 2 seconds if we fail to connect. Otherwise, we're going to be spamming the network like crazy for failed attempts. So if we do that, why have we not got anything? Oh, I know what we need to do. I presume that was crashing, but we didn't report here that data's changed. So that should now crash, and we hit here, turn on, crashes twice, maybe because we paused. Yeah, there we go. So now we can see there, error, insufficient localized information. We could also maybe do the time on the error, just so we know and we can see something updating. Date time dot now, and we just care about the hours, minutes, and seconds maybe. And then this should give us just a bit of a visual that it is reattempting to connect. There we go. So every 2 seconds, it's now going to attempt to connect to this multimeter. We're also showing that there's a problem. This is all nothing, which I guess is correct for not having anything. That makes perfect sense realistically, that there's nothing there. These buttons change mode, which that in theory shouldn't probably work in our real one when we do it. We want to make sure it does change. So let me go turn the meter on first. So that's the meter turned on and it's plugged into the network via Ethernet. So now when we turn on, I presume it's actually going to work. Nope, still not. So maybe we just got to give it a minute. I'm just going to leave that running a second. I've only just turned the meter on, and I'm going to presume, hopefully that'll work, because I've seen this code working in my test app. So I can only presume that either we have, maybe we just check the visa. Visa ID is nothing. How have we not got a visa ID? Did we just call connect and never pass in the ID at any point, or set the ID? Multi service dot Oh, enable changed, is enabled, blah, 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 is enabled as true. Yeah, we never set the ID up, so if it's enabled, we update that. At this point, I guess we should probably move that down to here, paste in the update, and we should actually set the multimeter.visa ID to the visa ID, otherwise it's never getting it. Right, so now that should work, hopefully. Turn on. Oh, yes. Oh, well, yep, there we go. So we've connected to the meter now, apparently. Now we return, obviously, just a random name, which is wrong, and we set this up. So that's the connected done. And the disconnect, let's check actually the disconnect works. And we want to make sure that we can connect and disconnect without screwing the meter up. Sometimes the meter seems to fault if you're constantly spamming the connections, but that's connected. Disconnect still says connected. Why is that the case now? We turned off and it still says connected. Disconnect, we do all that on disconnected. So turn on, connecting. That's actually connected, I think. But so this, something's going wrong with this update. This isn't firing. What's going on with this? Why are we not firing events? Is it because... Oh, this is our loop, I guess. So we can just check our loop, what's going on. Oh, where's the if ever connecting wait? What's going on here? Did we never finish that? If ever connecting wait 2 seconds. I swear we did this. I don't know where that went. It wasn't in the dummy, was it? No. I swear I wrote that code. I swear I put that in. So that now will, maybe that was just causing the problem. A massive 2 second delay between every action we were doing. So connect, connected, disconnect, and it still seems to be connected. So there's something wrong with the disconnect. Let's then figure out why. Now this should work because the logic's the same as the dummy, and we know the dummy worked. So we enable, it works. So we should have, if it's not enabled, disconnect. So we should, yeah, we're not hitting this. Why is this never hitting? Because is enabled is true at the minute, is connected is true, which is correct. So we want to break in here, if not, is enabled. So now this will hit as soon as we disable, hopefully. So that's not passing through. When we change the is enabled, have we screwed something up in here now? So enabled changed, right to file if it's enabled, set all these if enabled. So do we never call disconnect? Where did we call disconnect then? We're never calling disconnect. It doesn't make sense. We called disconnect before. Surely we did. Oh, we're only updating the is enabled if we're enabled. That's why. Move that out. There we go. Update multimeter service. So we did change the code. I just didn't notice the error. Right, so we can disconnect that. I'm pretty sure that's going to work now. Connect works. Disconnect. There we go. Dispose. I need disconnect. So connect, disconnect, connect. Perfect. So now instead of it saying this real, let's get the real device ID. If we look at this, then the next thing we did was we've opened the session, so that's good. We want to set the timeout actually. It's a network timeout. It was originally 2 seconds. I've now changed it to 20 seconds. This, I was having issues with it sometimes working, sometimes not. So we forced this to know that the line end is a new line. I think it's probably not an issue now, but I'm going to leave that in. So that's just configuring the session in connected. So if we go to here and let's just set up the session the same way. So that's that. Read buffer we probably want to keep as a variable. And that's just when we're reading the strings back from the multimeter, we need to store them in a byte array. Actually, we'll put that there. And this can be private byte array. Read buffer, that's fine for now. And then we don't need to do that. This is where we now read the name. So this will be the first thing to read the name. So delete that. And then obviously issuing a reset command. So we probably want to do the reading of the ID and then the reset at the same time. So it's all back to fresh. That just sets it up to default modes. So on the is connecting, I think we did have a place where we then called, was it in on connecting? We then went in here, fetch device name. So this is where then in device name, we need to try and do the right. We don't need to pass this session around now because we have the session already. So that can go. This can always be session. Same for this one. What's the problem with that? We don't want that to be static either. There we go. Oh yeah, session could be null as well, so let's make sure that's nullable. That's them fixed. What are we doing? Scroll down. Right here, yeah, so fetch. So now we want to identify and then ask for, we actually don't even need the read buffer. We just want to read raw string because the read buffer is now in here as well. So this is just going to ask the multimeter for a response. If everything goes well, that's all we care about. We're going to update the device name to literally whatever we get back for now. And that's it. So that should now ask the multimeter for its real name. And there you go. You've now got Rigel technology, and I can't see the rest. So let's just do, we'll probably do a view box around the title, mode title. Yeah, I'll probably do a view box around this, but let's also do a tooltip on it. Tooltip.tip equals binding mode title. And then, yeah, let's chuck this in a view box. So we'll want the bits here to go inside view box. Paste this in, and that should now grow. I presume, if that's all correct, that'll just grow to size like the other one did. So this should shrink based on the real name. Of course not. So do we need to do stretch fill? So it's not working, or have I got the wrong thing here? I got the wrong thing altogether. So we don't need that there. I'm on the wrong piece. I do that so often. Right, so it is the, I've even wrote notes so I don't do stuff like that, but still managed to do it. Header stack, header text. So here's the text here. So we want to probably, we just want this one to be a view box, just the big header. There we go. And then this wants to be stretch, probably uniform to fill. We want to fit, really. The margins we don't care about on this for now. Get rid of them. This wants to be why is that? That's over there. Horizontal line left. There we go. Device name. That's not stretching. No, stretching on. There we go. So Is that working now? Yes. Let's just put something in here a minute. That goes underneath. So this probably wants to also be vertical line bottom, maybe? And as it gets smaller, stays close to. Yeah, so undo that. Put that in there. Vertical line bottom. Is there like a max height thing? Yeah, max height. We don't want it growing too big, so let's say max height 40. Right, so turn on now. Whoa, that's a big name. So yes, that's probably the text we want underneath, and then we want a short name, which I don't know what we can do about the short name, to be honest. That still wants a tooltip. Tooltip.tip equals binding device name. Where's the tooltip gone? Is it just, or the view box rather? Let's just see if I can parse that name so we can use the real data, but obviously get something out of it. Of course, that's not working. There we go. Raggle Technologies, DM that, DM, wow, yeah, there's loads of info. So, because this is very specific to this one, I'm going to maybe search or specifically remove Raggle Technologies, replace comments with spaces. Nah, I'm just going to search for DM because I know this is a DM 3068, but we've got another DM 3018. I don't know what to do in this case. I can purposely look for the text between the two comments, or the two commas, I suppose. It's like obviously, this is very specifically designed for just mine at the minute. So we'll have the full identification here. There might be another identification code, but I'm not going to start digging into the API again. That took ages to figure out. So let's just do, I don't know, bar parts equals idn.split with a comma. I don't think this will crash. Maybe, I guess, if idn equals null, idn, let's just equal unknown for now, or say blank. There we go. So now if we split it by parts, if parts.length is greater than 1, then or in fact then we can just combine that, so we can almost make this a single liner. Parts.length is greater than that, it's going to be parts 1, otherwise it's just going to be the whole string. I think that'll do. So that should now try and find the item between two commas, or the item after the first comma, and use it. Yes, there we go. Now we have that. It's got a bit of a padding at the top I'm not a fan of. That's probably the max height, so maybe 50. No, it isn't. 40, 50. Well, 50 can be that, but oh, we'd got the margin you see before on the other one where we'd removed margin from top and bottom a little bit. There we go. No device, enable. Nice. We want the margin at the bottom actually. Probably on this label now. So probably the top wants to be more than the bottom. There we go. And now this has the hover to show more. So that's now the real multimeter name. That's not like something we've hard coded now. That's coming from the actual multimeter. Close, reopen. We've got that. Right then, we're on the home stretch now. So we've read that. We want to do the reset if we've managed to read the name as well. So we just need to go into here. We've managed to read the name. We should probably make this a helper function. Oh, it is literally a helper function for device read name. So let's leave it there. And let's just write a reset. And I guess we can, are we awaiting this? No. So let's ignore the sleep for now. That's fine because our method already sleeps for 200 milliseconds. So that's the reset. And what is next? So we get the initial config commands as mode commands and mode names. Those we don't care about. We have them somewhere in here. We did them somewhere here. So we've got the values ready to read here. Initial mode configured. Initial config mode, we don't care about that. Measure command and measure name, we don't care about that. So now we basically send a measure command and read the results. And then we're parsing the value, so we can figure that one out after. It doesn't really matter. We sleep, we increment the mode, and we cycle. So the only thing we need to do is, where did I change? I forgot to put the change. Current mode is index, is that mode? I think I forgot to write the code that I have got the code that changes. Let's just undo it all. I've definitely got the code that changes mode because it's this thing. Yeah, so mode commands is the. Oh, was that it actually? I think you don't change modes as such, you just read. You just literally send it to. I can't remember. I only did this about 3 days ago and I can't remember what I did. One of them does reader mode, the other one does change mode. But I think if you simply request to read a different mode, it changes mode the first time you request that. I think that's what it did. I'm sure that's what it did. So let's just double check my code first. So mode commands is that. Find the mode command. Yeah, it has to be. We just got the different command and sent it. So in terms of changing mode, then there really isn't anything you do except tell it what mode you want. So the mode change is actually fine. So mode change, we can just tell it we're in the mode, set everything up, and do this. So this code's actually completely fine. That's exactly the same as the dummy. Increment mode can stay in for the sake. Connector's done. We don't have an async anymore, so that's all fine. Disconnect works. Unconnected works. Fetch device name. That wants to make it easier, does it? What's it done there? Why is it removing that? Can this never be null? Is this because, I mean, technically, result is sessions that could crash, I guess. Otherwise, it gets a string, and okay, so it can't be null due to that, but it would crash if it didn't get the value, basically, so we didn't with a crash. That's fine. Same thing, I think, that if we fail to read a value, we probably don't want to keep spamming. So to be honest, we probably want error connecting as true, even though it's not error connecting. It is technically an error in one way, and then we'll cause that initial pause of 2 seconds, and actually, we needed to do an error for 2 seconds and clear it. Otherwise, it will just, as soon as it fails once, it's going to wait for 2 seconds. Clear error flag. So that's just like a timeout. If there's ever any TCP issues, it's going to time out waiting. This we don't need now. Fetch live value is the only thing left. So I think that loop is correct. This is now, that wants to be a bit slower, 5 times a second. This is recommending inside of the constructor we make it a method instead of just being inside of here. So we could do this and just call it a main loop, I guess, just to bring it out of the constructor. And then you'd normally move the main loop then outside of the constructor code, just to keep the constructor clean. Alright, so now we have main loop, infinite loop, do everything there. We connect, disconnect, and fetch live. I don't think there's anything else to do in that loop. Read and write we know works. Fetch live value. So now we get the read value string all the time based on the mode, which is correct. We have an unknown, so if it's unknown, we probably do want to throw, and well, if it's unknown, let's just read volts DC. Again, we don't care so much about throwing errors. We're not going to it's better just reading something than throwing an error for some unknown reason. So we'll just go into volt DC if unknown, basically. So this live value now we want to add back. So we need to now read the value. This is where we said in here, after we do all that, all we do is write that command and read it back. And it's that simple. So now we just need to write, and then the measure command is going to be, I guess this can actually be measure command because it's based on the mode. That will tell it to read the value from the multimeter, and then we need to read it back. So the result is whatever we read back. And for now, let's just dump that value in as a raw value. So that will just be result. I don't know if it's going to be a number, so let's just dump the result in for now and see what we get. And this should now read from the real multimeter. And obviously there's nothing connected to it, so it's going to be a floating value, I presume. And we have a result. But why is the live value not changing? Oh, it is. That was weird. And that's like once a second, which I suppose is, yeah, that's probably, again, a configuration on the multimeter. The multimeter has modes where we can set up how often it updates. Turning off, though, we've had an update after we've disabled, so that's obviously part of TCP. So what we want to do is, if we've started to fetch a live value, we've done this call, but by the time we get back, we want to make sure we're still enabled. Otherwise, we don't want to update. So, well, to be honest, if not enabled, just return, basically. And this is what you start getting when you use real, networking with delays. You've got to just handle situations like that. So if we turn on, I presume we just have to wait a second or two. I think the first mode it has to switch. There we go. And turn off. And then even though values will have come back after, it's going to ignore. Turn back on. The initial setup seems to take, a few seconds. And there we go. So I'm going to leave this running. I'm going to go into the other room and I'm going to probe a battery to see if this voltage appears. The problem is I'm not going to see that though. So we'll wait until we've done the rest of the code. I'm going to presume this is working. Now we want to display that nicer, because that's obviously not very nice. The problem is we need to go in every mode and see what we're getting back in order to parse the values correctly. So this will be voltage DC. And then if I go to voltage AC, I presume there's going to be a pause. So they see that pause, now it's waiting to change. And now that's voltage AC. Go into current, we wait, and there should be, nothing. So they're all numbers so far. That's a number. Resistance is a number. Capacitance, a number. Continuity now. This will be interesting. Is continuity not doing anything? Let's go back to resistance. Continuity. So I wonder if continuity doesn't read a value. What's that? That can't be the exact value, surely. Or is it? Okay, yeah, so continuity reads back 9. Is that maybe... Oh, that's just infinitely high. So I presume when you connect low, that's going to be a resistance value. That's quite cool. Temperature, probably a number again, I'm guessing. Infinitely high, maybe. Yeah, so the mode's working because we toggle between them. We get that. Capacitance. Yeah, so that's a number again. Diode mode. This would normally be like open line. So again, I think it's always going to be a number, basically. An open line is going to be this high number. That might be even like integer max. Frequency is a number. So they're all numbers. So we know we can parse this now safely as a number. Similar to what we've done here, try parsing. And I think what we'll do is the same kind of thing, try parse. Otherwise, we will basically try to convert to number. If it fails, just display it. because we might as well display whatever we got back if it's something. So if it failed to convert, we've got that. If it does convert, we want to do something with it now. So if we manage to get the double, we can do what we did before, which was to just set this value as a string of value colon 0.00 for now. Obviously, this can change then based on types. So we can do different processing, but now we can check. Oh no, we need to move that into here. So what we'll probably do, to be honest, is set the value, and then we can always override the value. So we'll do that, and then we'll say process process live value, and then this is going to move this to a new method and let us do something with the live value. So in this case, we want to say double value and do other things. And then in here, we need to pass in that value. So by default, we're going to just set the value, but then we're going to give it a chance to do other things to react to the real value. And in there, we can now do exactly what we did, which is, well, that logic is going to be different, so I'm going to keep that way. This should now react to the real voltage being these different values as well. And it should show, hopefully, the voltage DC as it did. And you'll notice we actually have a minus as well, which I didn't anticipate, but that's obviously correct. So now if we go to the different modes, we can see it's kind of rounding that value up to something more realistic. Yep, so it's just that the change of mode takes a little while to kick in. So I don't know whether on the mode change, we purposely clear the live value, because that just does take a while to change over. Whereas that is a massive number. So obviously, certain modes I need to handle differently. So continuity is either going to be below, say, 50 ohms, we class as continuity. So we want to show open line or connected. So I'll handle all these edge cases with, obviously, the custom codes. There you go. Now frequency is actually something that's correct. So it's showing, a high frequency. But this is where we want to probably tag like hertz or kilohertz and, process each value based on each mode. But I'll do that separately. That's not really anything specific to this. This is me finishing off the app. But I think that's all fully working. So let's just go commit this and take a quick look on the real machine. So this is my streaming setup. If you don't know or you haven't seen, if you go on to youtube.com/retro6, or you can search Retro6 UK into Twitch. We're also on TikTok, Facebook, Instagram, everywhere else. I stream most days, and we've got here, obviously, the desk setup. You'd normally see me having this kind of over here, and I'd be zoomed out, working on stuff, and then I'd toggle between cameras, which I don't know whether the others are set up yet. So we've got like an overhead camera here. I can pull focus like so, and I can show you like this is a clean juice we make, so I can measure some voltages on this. Now the problem we had was that obviously while we're doing this, the multimeter's over here, so to be able to measure stuff and for you guys on stream to see, I'd have to kind of zoom up and do things like this. So that's the whole point of having this stream electronics, the thing I've just made basically. So now what I can do is I can just overlay it on the stream directly like this, and this is just running on the PC. So if I probably zoom up, you can see there's the capture software. Here is my window, so this is just the normal software you see in here. If we connect, you can see the stream updates with what's on stream. So now I can move that out the way of the camera, have the camera say down here. I could even have it on the overhead camera like so. I'd have to just add that source back in because obviously I haven't set this up yet, so I just need to add the multimeter source here, so you can see it's now in this window. I can move this wherever, and instead of seeing all this, what we can do is apply a filter to this. So if I just simply apply a filter to the same color as the background, you can see that's now transparent. So now we have a semi-transparent meter. I can measure as well. Let's just measure, say, the battery voltage, and this should measure and come up with that color. So look how cool that is now, overlaid. And then to finish this off, I can just hold Alt and crop this down to, and this is why I've designed it this way, just show you that area. So now if I do that, we have this window, and I can reposition this wherever I want, shrink it down a bit, and have a nice little on-stream meter. And then I can obviously change between modes as well, and this just updates automatically. And then one thing I will add, well, multiple things I'm going to add, but if the value sits below, say, 0.1 volts for more than 5 seconds, I'm just going to fade this out completely so that you don't see it, and it can be running all the time, but it's not on stream. And then once I measure a voltage, it'll like pop back up on stream because there's a value there. So that's the whole point of this layout. It's like super easy to now see what I'm doing in terms of measuring voltages, or say you go to resistance and then turn this off and measure a resistor over here. That should be like 750 ohm, yeah, somewhere like that. So 675 ohm, and that's the auto ranging. So if I don't probe on right, it doesn't measure, and you let go and it goes into higher numbers. The other thing I'll obviously do is this higher number on the measurements, I'll also make it say like, 200k, and not say just a massive number. So we'll have like 200k, 1M, we'll do ranges of values for like thousands and millions and things. But that was the point of making this, so it's been a nice weekend project. It's now really easy for me to use my multimeter, turn things on, not have to worry, and I can also then go, if I measure this and see it go to orange, I kind of know it's in the 5 volt range. I've got a 34 volt one up here, so if I measure that one, we've got to turn him on, he's turned off. So if I turn on the 34 volt now and I measure up here, we should see it go to like fire. And there you go, so it's like, it's wicked. So you got like a nice fire burning visual, and then down here it'll go to orange, and then when you let go it goes to nothing. I can also get this updating a hell of a lot faster. So on the actual multimeter, you can see this one, I'll just hide this at the minute, I haven't obviously, like I say, set it up for view yet. On this multimeter, I've not really used it, I've had it for a long while and not really used it. You see this 10 here, this is the update frequency. So if I were to come out of control mode, so now this should be me controlling it, there we go, now I'm manually controlling it. If I say measure the battery voltage with this hand, he says, oh, I've got a single shot on, run hold, there we go. So see how slow this is at measuring. Oh, my multimeter's taken over again, the software, let me turn the software off a second. And now, yep, see it says in remote mode, so you have to press local to come out of it. And now I'm back to controlling it manually. If I measure the battery, see how it is slow at reading, and you let go and it takes a while to notice it's gone. That kind of slow behaviour. I can press left and right on here and change this value to update much faster. So now, ow, stabbed myself. So now if we probe with this, see how instant that was. So you just touch on, well, you can't tell what I'm touching, but I'm going to touch on now. It's like an instant read. And you can see how quick the value changes. So you can change this mode, and obviously, well, I could probably, if I get it in view of that, I can show you how quick it responds based on, changing that value. So we'll change that value in code as well. But when I touch on the battery, there you go, as soon as I touch on, it will instantly show. The release is slow because capacitive charge, but the minute you touch on, say, well, we'd have to turn on, so the minute I touch on the 5 volts down here, it's instant, like literally instant. Whereas if we were at 10, which is the default, it's going to do 10 samples, so see how much slower that is? Way slower. So that's the point of, obviously I can change these settings in our code and make it respond much faster. But yeah, that's the point of this. I'll then set this up, like say, per view, crop it down to wherever we want, and then the viewers can see just this, whereas I'll have the full control software. So now you guys can see just like a little multimeter up there, versus if you zoom out and look at what I can see while I'm streaming, you guys see that, but I've got the full control up here, so I can click between these modes, and I can control it and click these buttons, but you guys don't see the buttons, you just see the actual measurement. So it worked out perfect, looks really good, and now we've got a new overlay for a stream. Because this is software on Windows now and I've got access to the streaming software, I could also do anything. So I could change this entire stream,
I could automatically go to, say, an overhead camera if there's a certain voltage. I could maybe put a flame emoji up if we ever measure over 30 volts or something. So when we measure a high voltage, if we went to like that, I could then have a little flame emoji pop up on screen. Like, just as a cool thing, it just interacts with the stream more. So because I've now written this software, instead of you guys just seeing a boring value, we could change this visual to anything, as well as the fact that now we could do cool things on stream. So if certain things happen, one thing I wanted to do was, like, say in the continuity mode here, I want that to be red, and when we touch together and it beeps, I want it to be green. But what I could do is I could even make the entire border of the stream like go green when there's a connection, so that the continuity mode's a bit more interactive. There's just so many things I can do now. But this is the starting point. You've seen it all made. All that's obviously open source and you guys can download it. But now what I'll do is I'll enhance this, and I'll probably release it as either free software or like, you know, a small fee if anybody wants to use this. But you can use this version I've just made for free. But I'm going to add a load of enhancements to it for my stream. Possibly link it in with things like my soldering iron as well, so we can get soldering iron temperatures. It's really just a starting point. But yeah, that was a nice, enjoyable weekend project.